All right. So we're going to start off with doing oxidation numbers today, and we've already talked about oxidation numbers, right, with ionic compounds, right? So the charge that goes above the element, correct? Yes? And we're thinking that all the oxidation numbers are pretty well set for the transition. Today you're going to find out, not really. Okay? There are some basic rules that we've got to follow, and if an element doesn't fall under those rules, then we change it to what we need to change it to make the overall charge work. Okay? And this is going to seem a little bit confusing, and there's going to be a little bit of math that we put towards it. But if you pay attention and try the examples, and as soon as you get confused with one part, ask me right away so we can take care of it before we move further along the line. Okay? So if you need to stop at any time I'm talking, you need to ask that question right away. All right? So here is what oxidation numbers are, and this is nothing new about what they are. They're the charge above each element. We use those charges to figure out how many of each element we need when they combine. Okay? And we also use these to show movement of electrons in a chemical equation. That's when we get to the reduction oxidation part of the lesson. Okay? And so that's what this is saying. I'll let you fill this in and then I'll move on. Okay, so we've done a chart like this before about what do elements want to do, what do they want to gain, do they want to lose, how much and how many do they want to gain and lose. And so I'm not going to spend a lot of time on this, but just for an example, sulfur. How many electrons does sulfur start off with?
6.
Because it's in group 6A, right? That was unit 1 stuff, 8th grade stuff. Okay? How many does it want? First off, does it want to lose or gain to gain its octet?
Gain.
Gain, that's the easy thing to do, right? So it wants to gain how many?
2.
2. To get 2 plus 6 will give you that 8. Now, what's its oxidation number? So if I have sulfur, what number am I writing above it? If it gained 2 electrons?
-2.
-2, right? Nothing new, right? That's stuff we've been doing since the beginning of school. Okay? And that's why when I kind of put the rest of these up there, you can see what each one of those are. But once again, I'm very confident almost all of you can fill that table in without any issues. Correct?
Yeah.
Right? We've done this type of table before. Okay? So now what you need to know are some of those exceptions. The majority of elements can have many different oxidation numbers. So oxidation numbers can change, and they will change if they don't follow one of these rules. Okay? These first 2 rules have been getting my kids since the beginning of class all the way through, even though we've talked about it a couple of times. It's just one of those things that you have to keep reminding yourself about. Okay? So all elements in free state have an oxidation number of 0. Okay? Have an oxidation number of 0. So if I do the example of Fe plus oxygen gives me some type of iron oxide, what is the oxidation number of this iron? That means it's free state means it's by itself. I don't know if you want to write that next to what free state means. Free state just means it's by itself. Okay, it's not bonded to anything else. So what I'm going to do is I'm going to say, right now that iron has a charge of 0, or an oxidation number of 0. Okay? The next thing, all diatomic molecules, Brinkelhoff, also have a charge of 0. So what's my charge over O2?
0.
0. That's what those first 2 rules mean. Everybody kind of get it? That might be a little bit different way of thinking, because you're thinking, while iron is we don't know what its charge is because well, when it's by itself, it's 0. Okay? Oxygen, once again, when it's O2 by itself, it's 0. That's what those first 2 rules are. The next one, group 1 and group 2 metals are as they are on your periodic table. So the good thing is there's no change to those. All of your alkali earth metals and all of your alkali metals will always have that charge. So those don't change. Does that make sense? They will always have what is listed right there. What we have used this entire year since ionic, and we've learned about oxidation numbers. That's a good thing. The next one, oxygen will always be -2. Oxygen will always be -2 with one exception. The one exception is when we see it in peroxide, and then I want you to write that down. Now, I'm going to have you write it down right now, and in a little bit I'm going to give you an example, like sheet of a bunch of practice, and that's going to be on it, and I'm going to get a million questions of, well, how does oxygen work with -2 in this? It doesn't. It works with -1. Okay, or sorry, oxygen, right? It works with -1, not -2. All right, so make sure you have that down. The only time oxygen is -1 is when it's in peroxide. Don't forget about that, okay? Fluorine, and really almost all of your halogens are going to be -1, but definitely fluorine. The other halogens can change sometimes. And hydrogen is usually +1, except when it's with a metal hydride. But right now, hydrogen, on all of my examples, is going to be +1. Okay? So those are the rules. The biggest new ones for you are these first 2. And I put them in an example over here. And then you also need to know that if it doesn't fall in these rules, it can change. So nitrogen might be +3 right over here, but it might be +5 over here. All right? And there's going to be some pretty crazy numbers once we start doing the math for some of them. Okay? So, using these examples, all right? The sum of the oxidation numbers in a compound, overall charge of the compound. Okay? So, we'll talk about that here in a second. If there's no charge indicated, then the charge is 0. All right? So, when we look at Cl2, what's the charge over Cl2?
0.
Because that's one of your first rules, right? All diatomic numbers or molecules are always 0, like O2. When I look at KCl, does KCl have a charge attached to it? Do you see any +1, -1, +2? No. So we're always thinking if there's no charge attached to it, we're thinking that the total charge over this has to be 0. Right? Well, potassium, does that fall within a rule? It's the first 2 groups, right? So what's potassium always going to be? Which makes chlorine what?
-1.
Because when you put these together, their total charge has to be 0. And that works. Okay? Over here, KClO3. This one gets a little bit more in depth because we're looking at a polyatomic ion in here. And here's the first time I'm going to say this out of probably 4 or 5 times today. You have to be able to pick out polyatomic ions from a compound. It's important. Because I have to find the charge of chlorine and oxygen within that polyatomic ion. So keep that in mind. It's KClO3, right? So what's the easy charge up here to find oxidation number?
Potassium.
Potassium, because it has a set rule, right? What is it?
+1.
So potassium will always be +1. Now when I look at chlorine and oxygen, the only one in there that really has a set rule is what? With a what charge?
-2.
You see how that works real quick? -2. We'll go there. Here's where we have to do a little bit of math. Okay? If you look at your polyatomic ion chart on your periodic tables, what charge does chlorate have?
-1.
A -1, right? And that makes sense because when chlorate is paired up with potassium, the overall charge is what?
0.
0. However, when we just look at, is this chlorate,
Yeah.
right? Or chloride? Chlorate?
Chlorate.
When chlorate is by itself, what's its overall charge?
-1.
So what we need to do is figure out, when I add chlorine plus 3 oxygens, how am I going to get to -1? Does everyone understand kind of that math problem right there?
Kind of.
Chlorine plus oxygen need to add together to give me a charge of -1, because that's what the polyatomic ion is. Does that make sense? Okay? So now what I need to do is figure out what charge do I need to put to chlorine when I add it to the charge of oxygen, and there's 3 oxygens, to give me -1. Well, what's the charge of oxygen always? -2, right? So chlorine plus -2 times 3 gives me -1. Do the math. See what I'm saying? You got a little bit of math here.
-6.
So chlorine plus -6 equals -1. What does chlorine have to be?
5.
Not just 5, but a positive 5, because we're talking oxidation numbers. So oxygen is -2, chlorine has to be +5. Why does it have to be +5? Because chlorate has an overall charge of -1. So chlorine has to be +5 there. Okay? Remember how I said oxidation numbers will change? Look at chlorine here, look at chlorine here. And the math shows us that that is all correct. Any questions there? We're going to do a few more examples with those. All right? So, with these next handful of examples, the easy thing to do first is to come up with your total charge. What's my total charge on iron oxide?
0.
On aluminum fluoride?
30.
Overall charge?
-4. 0.
0. What about on phosphorus acid?
0.
Do you see a charge indicated? So what's the implied charge?
0.
0. So all of these are 0. Let me show you real quick before you start to get into these what I mean if it's not 0. So if you look here, what's the overall charge of sulfite?
-2.
You see what I'm saying? Of this one.
-1.
What about these two down here?
0.
Does that make more sense now? That you can see if there is a charge there, that's what it is. All right, so let's go back to these first two. Right? Total charge has to be 0 here. Correct?
Yes.
Does iron have a set rule to it? It does not. It's not in the first 2 groups. It's not oxygen. It's not hydrogen. It's not fluorine. Right? Does oxygen have a rule to it?
Yes.
What is it always?
-2.
So right away I can put the -2 over there. So if oxygen is -2, do a little math in your head. What does iron have to be to get to an overall charge of 0?
+2.
That's essentially what we're doing each time we find an oxidation number. Everybody got that? This one we said it was 0. Here's where it changes just slightly. You all need to pay attention to this. A little detail. Doesn't change, just a detail. Right? Fluorine, does it have a set rule? What is it?
Always negative.
Always -1. Right? Which means, what does aluminum's charge have to be? Don't say +1.
It has to be +3 because there's 3 fluorines.
There you go. +3. And watch this math because this is the detail that some of you might miss. Okay? Aluminum, if you just say +3 -2 or -1, you're thinking, well, that doesn't come out to be 0. That comes out to be -2. However, what total amount of charges is 3 fluorines bringing?
-3.
there's 3 fluorines, so +3 plus -3, -3, should give you 0. You see what I'm saying? However, when I list a charge, I only want one of those fluorines. Okay, that's going to be a pretty important detail when we actually get to the equations. All right? On the bottom, the scale that you need, pick out your pi-atomic ion. Right?
This one's not have that one on our paper.
That's fine. We can still do this because this is a good one to practice with. So right now, what is hydrogen always?
Plus one.
For the most part, it's +1. And we're thinking, how many hydrogens are there?
3.
3, right? 3?
Yes.
So how many total charges is hydrogen bringing to like this party?
+3. +3.
Does that make sense?
Yes.
A total of +3, but each hydrogen is +1, which means the overall charge of this phosphite should be what?
-1. No, -3.
-3, correct? And if you look at your chart, that's what it is. Like your pi-atomic ion chart, that's what it is. Correct?
Yes.
So now we need to do a little bit of math to figure out, well, what's the easy one in here? Phosphorus or oxygen? Is always what?
-2.
So we can put a -2 over there right away. Now we need to do a little bit of math in our head or on the paper to figure out what phosphorus is going to be. Because 1 phosphorus plus 3 oxygens with a -2 charge. Everyone understand where those numbers came from?
Yes.
We have 3 of them at a -2 charge. Needs to give me what? A -3 charge. Because that's what the charge is of all of this overall. Correct?
Yeah.
So if I do it, once again, I've solved this equation. Plus -6 needs to give me -3. What does phosphorus need to be?
+3.
+3?
Yeah.
And there you go. Right? It's not extremely difficult if you take your time. Next one. Next step. I'll do one more with you, and then I can kind of let you finish out the rest of the examples for this. Right? We have sulfite. Right? What's the overall charge?
-2.
So I'm going to put that there, -2, because it's indicated what that charge is. Okay? So now I know what's the easy one to do first, because it's always -2. Put -2. So once again, if I do a little bit of math, sulfur plus 3 oxygens with a -2 charge each needs to give me -2. And some of you can do this in your head once you understand where the numbers come from. Some of you will have to write it down every time. Sulfur plus -6 needs to equal -2. What is that magic number for sulfur?
+4.
+4. Do you understand what we're doing and how these numbers can change? Use your rules. Find which one is the easy one from your rules to write down. From there, whatever one, doesn't fall under the rules, you make it what you need to make it for it to work out to equal the correct charge. Go ahead and try to do these next 3. If it's an emergency, you can go. Jacob, what's the overall charge of this one?
-1.
-1. Karen, what's the charge of oxygen right here? -2, right? And that should be, hopefully you remember that. It's like you don't have to look at the rules, you just remember that one. That's the easy one to always put down, right? Now we need to calculate for chlorine. When I calculate for chlorine, I know we have to get to -1. Well, I have chlorine plus -2 charge for 4 oxygens, which means chlorine plus -8 has to equal -7, -1. So Jaden, what does chlorine have to be? What plus -8 will give me -1? That'll give me a +1, there you go. 7, +7. So what you're saying there is chlorine's losing 7 electrons? Yeah. Yes. Okay? That's the math that makes it work. That's what happens there. Okay? Let's do H2SO4. That's the next kind of difficult one. Pick out your polyatomic ion, which is sulfate. Hydrogen will always have what charge, Kyle? There you go, +1. +1. Moving to oxygen. -2. Okay? Now the tough one is sulfur, because it doesn't fall underneath any of the rules, right? So I know that if hydrogen is going to carry +1 and there are 2 of them, technically it's bringing how many charges to the party? +2, which means sulfate has to have an overall charge of what? -2. So when I do the math, I have to get this to equal -2. Do you all understand that?
Mm-hmm.
Like, have we done that enough? That's got to be, both of these have to come out to be -2. When I do the math, sulfur plus 4 oxygens with a -2 charge each, that's what the math looks like. So sulfur plus -8 has to equal -2. So what's the magic number there, Memphis? 6. +6, right? And now the overall charge would be 0 there. Any issues with that? Okay? So, go to the sheet that I just passed out to you.